Differential Calculus. In previous video we discuss about function. It is an expression, rule, or law that defines a relationship between one variable, the independent variable, and another variable, the dependent variable. For example, in given equation, y equals x plus 1. Y is dependent variable and x is independent variable, so we can say y is the function of x. It is written as y equals f, x. Differential coefficient or derivative. In equation y equals x plus 1, y is the function of x, so we write y equals f, x. If we will change the value of x, then the value of y will also change at the same instant. So the instantaneous rate of change of y, dependent variable, with respect to x, independent variable, is called the differential coefficient or derivative of y with respect to x. It is denoted by dy divided by dx. Common derivatives. 1. If y equals c, constant, then dy by dx equals 0. That is, the derivative of any constant is always 0. For example, if y equals 10, then dy by dx equals 0. Common derivatives. 2. If y equals x raised to power n, then dy by dx equals nx raised to power n minus 1. For example, if y equals x raised to power 5, then dy by dx equals 5x power 4. 2. If y equals x power minus 5, then dy by dx equals minus 5x power minus 6. Common derivatives. 3. If y equals c into x raised to power n, then dy by dx equals n into c x raised to power n minus 1. For example, 1. If y equals 4x raised to power 5, then dy by dx equals 5 into 4x power 4 equals 20x power 4. 2. If y equals minus 3x power minus 5, then dy by dx equals minus 5 into minus 3x power minus 8 equals 15x power minus 8. Common derivatives. 4. If y equals u plus v, where u and v are the function of x, then dy by dx equals du by dx plus dv by dx. For example, if y equals x raised to power 5 plus x raised to power 4, then dy by dx equals 5x power 4 plus 4x power 3. Common derivatives. 5. If y equals u plus v, where u and v are the function of x, then dy by dx equals du by dx plus dv by dx. For example, if y equals x raised to power 5 minus x raised to power 4, then dy by dx equals 5x power 4 minus 4x power 3. Common derivatives. 6. If y equals u into v, where u and v are the function of x, then dy by dx equals u dv by dx plus v du by dx. For example, if y equals x raised to power 5 into x raised to power 4, then dy by dx equals 9x power 8. Common derivatives. 7. If y equals u divided by v, where u and v are the function of x, then dy by dx equals v du by dx minus u dv by dx whole divided by square of v. For example, if y equals x raised to power 5 divided by x minus 1, then dy by dx equals 4x power 5 minus 5x power 4, whole divided by square of x minus 1. Derivatives of trigonometric functions. 1. D by dx of sine x equals cos x. 2. D by dx of cos x equals minus sine x. 3. D by dx of tan x equals sec square x. 4d by dx of cot x equals minus cosec square x. 5d by dx of sac x equals sac x tan x. 6d by dx of cosec x equals minus cosec x cot x. Derivatives of some other functions. 1d by dx of ex equals ex. 2d by dx of log x equals 1 by x. 3d by dx of sin u equals cos u into du by dx. 4d by dx of cos u equals minus sin u into du by dx. 5d by dx of tan u equals sac square u into du by dx. 6d by dx of cot u equals minus cosec square u into du by dx. Geometric meaning of derivative. Geometrically, the differential coefficient of y equals f, x, with respect to x at any point is equal to the slope of the tangent to the curve representing y equals f, x, at that point. That is, dy by dx equals tan theta. Chain rule, differentiation by substitution. If a variable y depends on the variable t, which itself depends on the variable x, that is, y and t are dependent variables, then t, via the intermediate variable of y, depends on x as well. In this case, the chain rule states that dy by dx equals dy by dt into dt by dx. Derivatives of higher order. Derivatives of derivative are known as derivatives of higher order. For y equals f, x. Derivative of first order is dy by dx. It is represented by f dash, x. Derivative of second order d2y by dx square represented by f double dash, x. In this order, derivative of nth order is written as dny by dxn represented by fn, x. Maxima and minima. A quantity y depends on another quantity x in a manner shown in figure. It becomes maximum at x1 and minimum at x2. At these points the tangent to the curve is parallel to x-axis and hence its slope is tan theta equals 0. But the slope of the curve equals the rate of change dy by dx. Thus, at a maximum or minimum dx by dx equals 0. Just before the maximum the slope is positive, at the maximum it is 0, and just after the maximum it is negative. Thus dy by dx decreases at a maximum and hence the rate of change of dy by dx is negative at a maximum. That is, d by dx of dy by dx is 0 at maximum. Derivatives in physics. Derivative in physics are used widely. For examples: 1 instantaneous speed v equals ds by dt. 2 instantaneous acceleration a equals dv by dt. 3 force F equals dP by dt. 4 angular velocity omega equals d theta by dt. 5 angular acceleration alpha equals d omega by dt. 6 power P equals dW by dt. 7 torque tau equals dL by dt. And so on. In next video we will solve problems on differential calculus. Created by 4. Physics 21. Please like and subscribe.